Now, let's talk a little bit about what makes up a good night for observing. When you're preparing for a night under the stars, clear is only half the story. To truly understand what your telescope can do on a given night, you need to differentiate between transparency and seeing. Think of it like looking through a window. Transparency is how clean the glass is, while seeing is how much the glass is warping or vibrating. Transparency, the clarity of the air. Transparency refers to how much light from space actually makes it through the atmosphere to your eye. It is primarily affected by moisture, humidity, dust, smoke, and light pollution. For high transparency, the sky looks inky black. Faint stars are visible all the way down to the horizon. It is best for observing faint fuzzies like nebulae and distant galaxies, for example the Andromeda Galaxy or the Orion Nebula. Under low transparency, the sky looks milky or hazy. Only the brightest stars are visible, and the background sky looks grayish. When transparency is poor, these objects will simply vanish into the background glow. Seeing, the stability of the air. Seeing refers to how steady the atmosphere is. Turbulent air, caused by temperature shifts, wind, or the jet stream, makes objects twinkle or appear to shimmer and boil. For good seeing, stars do not twinkle. They look like steady points of light. When you look through the eyepiece, the image is crisp and still. It is best for high magnification work. On the Moon and planets, for example, Saturn's rings or Jupiter's Great Red Spot. Under poor seeing, stars twinkle aggressively. Through the telescope, a planet might look like it's underwater or constantly drifting in and out of focus. If the seeing is poor, you won't be able to crank up the power without the image turning into a blurry mess. The balancing act. Quality versus stability. It is quite uncommon to experience a night where the atmosphere is both perfectly still and perfectly clear. Instead, we usually have to compromise based on recent weather patterns. Post-storm clarity. After a cold front passes, the rain often scrubs the atmosphere of dust and pollutants, leading to spectacular transparency. However, the accompanying cold, moving air often causes high turbulence, which degrades the seeing and makes stars appear to twinkle rapidly. Summer stagnation. Conversely, hot, humid summer nights often have heavy, hazy air that limits transparency. Because that air is so heavy and still, the seeing can be rock steady, allowing for high magnification views. Selecting your observing targets. You can use these conditions to plan your session effectively. Deep sky priorities. When the sky is inky black, but stars are twinkling, focus on low-power views of galaxies and nebulae. Planetary priorities. If the sky looks a bit milky, but the stars are steady points of light, it is a planetary night, perfectly suited for the Moon or the rings of Saturn. The social night. On nights where both conditions are poor, use the time for gear maintenance, testing new accessories, or simply enjoying the camaraderie of fellow TSA members in our discussion group. This graphic serves as a quick visual reference guide, allowing you to quickly identify how current atmospheric conditions impact what you can expect to see through your telescope. Transparency, clarity. Focuses on inky black darkness. Poor transparency, a rating of less than 3, is milky or washed out, making faint targets, like nebulae or galaxies, difficult to observe. Good transparency, a rating greater than 3, is sharp and clear. Seeing, stability, measures atmospheric turbulence. Good seeing, a rating of greater than 3, offers stable, crisp images that are ideal for high-detail planetary work. Poor seeing, a rating less than 3, makes objects appear blurry or distorted, like looking through moving water. This will help you prepare for a successful night of observing.